And this one is longer, as you can probably tell by the length of the video. I'm predicting it to be longer than the last couple. This is another typical question that we did in the grade 11 course, one of the harder questions. So in this example, I'm walking my 10 kilogram pug Charlie. We're going to use 10 kilograms. That's how I originally wrote it. Like I say, he's not 10 kilograms anymore. He stops to sniff a tree, and I want to get him going again. I apply that much force on that angle, okay? And this is just enough to start to drag him away. So that just enough to start, that to me says FS is going to be in there, static friction, okay? So we want to do all these steps. So let's go ahead and do them. The free body diagram on Charlie. I guess, you know, I told you already how you draw the ball. You write down all the forces. Notice I did fax and Fay, FAX, FAY. That's because even though my force is 65 newtons on an angle, like up here somewhere, I don't draw those things. I don't draw the angles because we don't do force balances on angles. We do force balances in the horizontal direction and in the vertical direction, okay? So far. There is new stuff coming up where we don't, but anyway, and again, like I said, it's going to be static friction because we're talking because of the words just enough to start. That's the trigger to me that it's static friction. Okay, so that's the free body diagram. Now we want to find the gravity force on Charlie. So we're using 10 kilograms, oh, I did use 13 kilograms. I thought I'd use 10 for the question, but I must have changed it when I wrote it out. So 128 or 127 newtons, and you know, whether that's a good answer or not, I'm going to check mark it anyway. 10 times 13, right? Okay, always, best math you can do is just to do some estimates, right? So round that to 10, and then it should be about 130 newtons. Part C asks us to find fax and Fay. You might remember from last year that fax in these questions is always cosine for x and sine for y. The reason is the way I draw it, right, there's my vector, my 65 newtons, 35 degrees above the horizontal. So there's my horizontal, that's 35 degrees above it. So then FAX is here, FAY is here. So FAX over 65, adjacent over hypotenuse equals cos, okay? And then likewise with y. Okay, so you just solve for those, you get numbers, kept a couple decimal places. This isn't my full answer, so I'm going to use as many decimal places as I can throughout the solution. Okay, look at normal force is the next part. The big thing with normal force is, unless you have a question, which we might have a question, we will have a question this year where you are in something that's moving up or moving down, but you know, most of the time it's sliding sideways, so up equals down. There's no up or down, like it's not moving up or down, so therefore the net force is 0. So whatever's in the up on your free body diagram has to equal whatever's on your down. So my up forces are normal and FA, and my down is gravity, so I can solve for normal that way. Okay? Just plug in the numbers and get 90 newtons. Pause if you need to, of course. Static friction force, the same idea. If you're looking at just enough to get started, your static friction, you can use forward equals back. Okay? And again, we did this last year, so fax equals FS, so FS is the 53. Well, here's my little note. You don't have to write this stuff out. Like, don't write anything out if you don't think you need it. This is just a little thing. Try to keep as many decimal places as you can tolerate when you're solving a multi. So many of our problems, especially in this 4U course, are quite long. And if you could, ideally, you would never plug a number in your calculator till the very end. That would be ideal, because then you would have sort of the maximum accuracy. Because every single time we round, every time we write, that was my dog snoring, by the way. Every time we round, you lose accuracy in the question. So as many as you can. All right, but anyways, last part, looking for MUS, FS over FN. We know FS, we know FN. That's definitely a good answer because it's between 0 and 1. Good work. Sorry it's so long.